Hello and welcome. My name is Christopher Michael. I'm going to do a live demo here of the Wayfire OpenGL Wayland compositor running using Pixman, which I know it wasn't meant to do, but that's okay. By the way, this is actually running on the Pi. It's going through a video capture. But anyway, okay, so as some of us know, the latest bookworm Raspberry Pi OS was released last week, along with the announcement of the RPI 5 device. The RPI 4 and the RPI 5 will come by default running Wayfire using OpenGL. However, because it's Raspberry Pi OS, we want to have the same experience across all the devices. So we need this basically Wayfire OpenGL compositor to run on RPI 1 through 3 also, which obviously we can't do with OpenGL. Oh, come on, mouse. There we go. So the challenges that we face doing this. Wayfire itself is strictly written for OpenGL. There was no software rendering at all on that. From previous XDCs, you may remember that on the RPI 3 and below, we can run out of GPU memory when using OpenGL. So obviously, we can't render the desktop with GL. So the solution we come up with was to implement software rendering inside the Wayfire compositor. However, we did still want hardware-accelerated apps to work, such as GLX Gears, GLMark, things of that nature. So it proved to be a little bit of a challenge. This demo is going to run on the RPI 3, which was released in February 2016 with a quad-core Broadcom 1.2 gigahertz, a Giga RAM, and the GPU does not have any MMU. So what I wanted to show is that even though this is software rendering, we can still get hardware acceleration. I mean, there's the obligatory GLX gears going on. And that's not using LVM pipe, that's actually using the VC4 driver. We also have GLMark II. Basically anything hardware accelerated will work. Where was... I was told I had to display Neverball. No, I've never played this game before, so bear with me. Whee! Okay, that was fun. Okay, I can see how this would be addictive. All right, let's get out of that. There we go. Okay. We also, I don't know if it's on. No, okay, it's not. And then we have ELS or ES2 gears, the Wayland version running. So it is hardware accelerated. It is a Wayland compositor. We did have some issues in doing all this, which, come on, mouse. There we go. A lot of the plugins in Wayfire are written strictly for OpenGL using various GL calls. So one of the issues that we had to do is go through all the plugins in Wayfire, which are quite a few, if you've ever looked, and basically modify the code so that we can run via software in cases where we could modify the code. There are places where we could not. We ended up having to implement a new Alt-Tab switcher, which we can show here. And actually, it might be better if I had another window open, huh? we go. So, I mean, it's a fairly basic Alt-Tab switcher, but it does function quite well. They also have, what was it, these two. The Alpha plugin that's in Wayfire does work in software. And then we were also able to do the Zoom plugin. Might be going the wrong way on the mouse here. Let's see. Yeah, there we go. Which also does, work using software, and actually works quite well. Thanks to Lucas. Thank you, Lucas. So to achieve some of this higher performance, we ended up having to do some kernel patches to use, non-coherent buffers. Are those getting upstreamed, those patches? Do you know? No idea yet? Okay. And we also make use of DMA buffs and modifiers to import the application surfaces. This is still a work in progress. There are still a couple issues to sort out and a few more plugins to get working properly. However, it is on its way to becoming fully functional. Oh, well, I've reached the end. That was a fast 10 minutes. So I guess now we'll have some time for some questions if you'd like, or if I could display a few more applications. I don't know what else to run, though. We did the GLX gears already. Yeah. Don't think we had any other apps we were going to display, did we? It was the gears, the GeoMark. Yeah, that was kind of it. So, any questions? Oh, I see a few hands. All right.
Hello?
There you go.
Okay, so these patches that you were talking about that are still not upstream, is it something specific to Raspberry Pi enablement, or you can run this in other hardware as well?
Currently, the kernel patches, I believe, were specific for the Pi, but you can run the software rendering in basically anything. It doesn't have to be a Pi. But those patches we have not upstreamed yet. We still have some WL roots patches to upstream also.
So you can run the software rendering with accelerated applications in other hardware as well?
Correct. You should be able to. Yeah, as long as the hardware supports it, absolutely.
Is that working? Yes. Could you give any background on why Wayfire has been chosen for the
I
compositor?
can't speak too much to that. It wasn't a decision that we made. That was a decision from RPI.
Okay. Is it something they've created or something that another project?
No, Wayfire is an existing compositor. You can run it on any desktop right now. Yeah, it's not a separate project or anything. It's not something specific to RPI, no.
Yes, sorry, I'm going to go back to Eriko's question.
Sure.
So the patches you have for VC4 are to allocate non-coherent buffer, right?
Mm-hmm.
Because otherwise you would get CMA buffers,
which you'd end up running out of memory.
Yeah. So, yeah.
Mm-hmm.
So on ARM and ARM64, I think you have a DMA buff heap that already allows you to allocate those kind of buffers from memory and then get a DMA buff handle.
Right.
Why wasn't it a solution for you?
What? Oh, what made the hardware acceleration work?
No, I mean, why didn't you use a DMA buff heap to allocate those non-coherent buffers?
That's a good question. Yeah, it's sort of, yeah. Go ahead, Lucas.
Yeah, well, we can discuss it later if you want.
Sure.
So one of the big problems with them is it's not us that are allocating the surfaces. It's things like Mesa that's allocating the surface, or it's X11, GLX.
Okay.
X Wayland, that stuff. So there's a lot of places where you'd have to modify it, where those things just use the DRM APIs directly. And so if you fix it if you change the way the DRM APIs work on VC4, then it fixes it for everything, as opposed to having to make this change in all these other places.
Okay, makes sense. Thanks.
Any other questions?
So you said the motivation for using software rendering was because you're running out of VRAM?
On the older devices, yes.
Yeah, so I'm just curious about like how much VRAM do the older devices actually have?
I guess that varies by model. I mean, the B plus probably has more than the regular B.
Yeah, because like a 720p frame buffer would be like 3 megabytes or whatever, so it must be really small.
On the RPI devices, yeah, it's a bit limited. I don't have exact numbers in front of me. But,
Yeah.
Okay.
I can answer that a little more.
Okay.
Yeah, so the Pi 1 through 3 don't specifically have VRAM. The issue is that there's no MMU behind the
Right.
GPU, and so you're relying on Linux's CMA allocator, which works sometimes, and then sometimes just says no. You don't have a specific number of, you can allocate this much memory. It's fragmented, other things get pinned into it. You get no mem out of it all of the time. And so this software rendering plan is the workaround for, we can't put every buffer into CMA because
Correct.
the kernel just says no.
Yeah, exactly. Thank you for that. Any other questions? Okay, well, thank you for your time.